So let's take a look. So how do you start the thing? So for the Windows people, you will have a folder, so it comes as a zip file. You unzip the zip file. That gives rise to a folder, and in that folder you will have a batch file. So run fastqc.bat. When you double-click this thing, it will open a black screen like this first, and then it will open a tool that looks like this. Well, in your case it will be empty because you don't have data open. Or how can you analyze data here? Well, that's very simple. You simply go to File, here at the top, you click Open, and then you select a FASTQ file. So you have downloaded one, so you simply select that one. As a zip file, you don't have to unzip it first, and then you click Open. And it will take some time to open, it will go slow, but that's because when he opens it, he's automatically already analyzing it. So once it's open, the analysis is completely done. So let's start here with the basic statistics. This is a table where you can find these things. These are the interesting things. Yeah? You will find the encoding there. Here, that's this line. In my case, he's saying here, Zanger Illumina 1.9. What this means, we will talk about this later, but this is basically related to the ASCII encoding. FastQC actually guesses the ASCII encoding of your FASTQ files by checking the quality scores. So on the slide, you can see how to interpret the information that he gives in the report. So when he speaks about Zanger data, he assumes that it's ASCII 33, for instance. If he says it's Illumina 1.3, then he assumes that it's an ASCII 64 file. For Illumina data, the offset can either be 33 or 64, you don't know. Although if your data are very recent, you can be sure that it's offset 33. Aviti data, on the other hand, will always be offset 33. So this is important. Then you have here the total number of sequences. When you go to your sequence provider, he will ask you, how many reads do I need to generate per sample? And then you tell him 10 million, 20 million, 30 million. Yeah? So what you tell him and what you pay for should correspond to what you see here. If not, you have to complain. So this is an example of an Aviti FASTQ file that was opened in FastQC. So you can also use FastQC on Aviti files. What's typically different is the number of sequences. So here we have a whopping 86 million sequences. That's a lot. There's also a line called sequences flagged as poor quality in the basic statistics section of the FastQC report, and as you can see, it shows 0, and that's completely normal because Illumina doesn't do any flagging of reads based on quality. Also, Aviti is not doing any filtering or flagging of reads based on quality, as you can see here. And then what is also important here is this, the sequence length. So this is the length of your reads. So you see that in this experiment, we have reads of 36 bases. That's small, but for RNA-seq, that's enough. Well, if you only want to look at differential expression, that's enough. Why do you have to watch this also? Well, because when there's one number here, then you're probably looking at raw data. Nobody has touched them yet. But when you see two numbers here, someone has already processed your data. They have already cleaned your data. And that's not bad, eh? But you will have to ask your sequence provider what he has done, because you need to mention it in your publication, of course. When you look at the sequence length line in the report of the Aviti FASTQ file, you see that the situation is different from the Illumina data. So here we do have two values. So, and these values represent a range of lengths of the reads. The smallest read in the file is 16 bases, the longest read in the file is 75 bases, and you have reads with lengths in between. Where does this come from? Well, it comes from the fact that the basis to FASTQ tool can also remove adapter sequences from your reads. And by doing this, it will shorten the reads, and that's exactly what you see here. That's of course not a bad thing. You have to remove the adapter sequences from your reads, but you have to double check with your sequence provider to see if this is indeed what happened with your data.